You.
Hello, are you still there? I hope you can all hear me. Sorry for the break. Let's just continue. So we are on decimal number system, and I've given an example here. Then hexadecimal number system. So hexadecimal number system is based on is a base 16 system, and because it is base 16, so it has 16 digits from 0 up to 15. But the difference is when it gets to 9, the next digit after 9 is A, and the last digit is F, which is equivalent to 15. So in this system, we have the weighting is raised to the power of 16. For instance, now if you have A1F in base 16, the equivalent value in decimal would be A times 10 raised to the power 6, A times 16 raised to the power 2 plus 1 times 16 raised to the power 1 and F times 16 raised to the power 0, which is 2,591 in base 10. I hope you understand this. So another example is given here. 251, 2,591. Okay, it's the same example. Anyway, it's the same example. So how do we now convert from one base to another? So from binary to hexadecimal, it is very possible to convert. You have seen how we have been converting from other base to decimal. We converted from binary to decimal, we converted from octa to decimal, then we converted from hexadecimal to decimal. So how do we convert from binary straight to hexadecimal? For this conversion, so for this example, we have the number for hexadecimal is grouped into 4 digits. So when we group it into 4, then we then find the equivalent value of that 4 bits in binary. So here is an example so that you can get it well. We have 1011 00111 010 is in hexadecimal. To convert this into, this is in binary. To convert this into hexadecimal, we break it into group of 4. So we have 1011, we break it, 0011, we break it, 1010, then we break it. So we convert, what is 1011? 1011 is actually 11. And 11 in hexadecimal is B. That's why we have B there. Then 0011 is 3. That's why we have 3 here. Then 1010 is 10. And in hexadecimal, 10 is A. So we have B3A in hexadecimal. But to convert back to binary, we reverse this operation. So you can try, whenever you see A, A is 10. Remember, A represents 10 in hexadecimal. So you convert 10 to binary. Convert 10 to binary. Then convert B, which is 11, to binary. Convert C to binary, then D to binary. You join them together. That is your hexadecimal to binary. So that is how we do conversion from one number system to another number system. Now, all the conversion that we are doing, all the number representation, you notice that they are actually positive numbers. They are positive numbers, but how do we represent negative number? To represent a signed number in number system, there are different methods, but one of them is the sign and magnitude representation, because the sign has to be represented as well as the magnitude. The magnitude is actually the number, and the sign is either positive or negative. So we have two ways: sign and magnitude representation and the two's complement representation. For the sign and magnitude representation, the leftmost bit of the number, which is the most significant bit, is used as a sign bit. You use it as the sign for that number, and the remaining bit is used to represent the magnitude. So by convention, 0 means positive. When the most significant bit is 0, then the number is positive. And when the most significant bit is 1, then the number is negative. So here is an example. We have -5 is represented